This next section of notes is going to cover the Milky Way and other galaxies. Our definition of a galaxy is going to be a collection of stars, dust, and gas that are going to be bound together by gravity. These galaxies can include millions to billions of stars and many different types of stars. What happens is gravity will hold these galaxies together, and even if we did not have gravity, all of space would just be a veil of gas. And so our solar system usually revolves around the center of that galaxy, and what you'll see is the different shapes of these galaxies are formed by how they rotate. Galaxies are not evenly spaced due to gravity. Galaxies that are close to each other can form into clusters. A cluster is just going to be a group of stars or galaxies that are bound together by gravity. The Milky Way, which is our galaxy, and Andromeda, which is our neighboring galaxy, are two of the largest in what is known as the local group. There are three main types of galaxies. The first one is a spiral galaxy. The Milky Way, where Earth is located, is a spiral galaxy. It is classified as this because of the huge spiral disks of stars, gas, and dust that give it very distinct arms surrounding the center. The nucleus is going to be made up of a dense collection of old stars, and then the interstellar matter is going to be the gas and dust that is going to be located between those stars within a galaxy. So you can see these two pictures on the right side. We have our dense cores within the center, and then there's very distinct spiral arms surrounding that center. The second type of galaxy is going to be an elliptical galaxy. These galaxies are spherical or egg-shaped, and they're made up mostly up of older stars with very little interstellar matter. They usually are reddish in color due to the older stars that they contain that are closer to the end of their life. The third type of galaxy is going to be irregular galaxies. These galaxies lack regular shapes and they have no well-defined structure. These odd shapes may be due to the gravitational influence of nearby galaxies or other objects that are more massive. It is very hard to study these galaxies because scientists cannot know what faraway galaxies look like because of how long it takes light to reach Earth. So, by studying closer galaxies, we can slowly piece together how galaxies evolve and change throughout time. This is still an area of science that is very much unknown, and scientists are looking forward to expanding upon this area in the future. There are changes in galaxies that do take place. Quasars are thought to be infant galaxies or very beginning galaxies. They usually have a very luminous object that is producing energy at a high rate and that are thought to be the most distant objects in the universe. Each quasar has a huge central black hole and a large disk of gas and dust that surround it. Galaxies also change as they use up their stores of gas and dust. Collisions can also change how galaxies are shaped. The galaxy's shape may also change due to other gravitational attractive forces. And then new stars that form within the galaxies can change how the actual structure of the galaxy is made up as well, as those clouds of dust and gas collide and can form bigger stars. Now let's look at the origin of the universe. The universe is all space, matter, and energy as it exists now, in the past, and in the future. When we see the universe, we see it as it was in the past. And this goes back to the fact that, once again, it takes so long for that light to travel from those objects to Earth. So we're actually studying things as they looked in the past and not currently as they are now. Most of our universe is going to be made up of empty space. Scientists have long theorized that the universe was formed due to a cataclysmic event known as the Big Bang, and thus we have the Big Bang theory. This is the theory that all matter and energy in the universe was once compressed into a small volume and has since exploded from that small volume and expanded in all directions. In order to support this theory, scientists actually have some evidence to show that the universe is currently expanding. What they use is spectral lines that show other galaxies as they're moving away from us. A red shift gives us longer wavelengths, indicating that an object is going to be moving away from its observer. And this is explained by the Doppler effect. Doppler effect is an observed change in the frequency of a wave when the source or observer is moving. You may have experienced the Doppler effect if you've ever been out on the road or driving in your car and you hear an ambulance. As that ambulance siren is buzzing and it goes by you, as it comes closer to you, the pitch changes, and then as it moves away from you, those wavelengths get longer, and so the pitch changes once again. That's very similar to the Doppler effect. So these longer wavelengths that we see indicate that an object is moving away or further away from the source, which would be Earth. This outward expansion thus implies that the universe was once smaller. Scientists believe that the universe was extremely small space at one point, and then matter appears to be expanding rapidly in all directions, and thus comes the idea of that gigantic explosion sending matter in all directions. The second piece of evidence that is used in order to support this theory of the Big Bang is the cosmic background radiation that is left behind. What scientists have found is that there's a cosmic background radiation, while it's very dim signal that's located all over the sky in the form of radiation at the microwave level. And so these microwaves that are left behind energy from that Big Bang are believed to be remnants of the evidence supporting the Big Bang explosion. So according to the Big Bang theory, all matter and radiation expanded outward. It cooled, thus forming our protons, neutrons, and electrons. And while this is just a theory, it is constantly being tested, revised, and redefined as new information is being discovered. So what does the future look like for the universe? Scientists believe that the future of the universe depends on the mass that it makes up the universe. If there's not enough mass, gravitational pull will be too small to stop the expansion. And so what will happen is the universe will just continue to expand outward in all directions. If there's just the right amount of mass, then expansion will eventually continue to slow down, and then, but it will never completely stop. It will just be slowed down. If there's too much mass, what's going to happen is gravity will eventually overcome the expansion forces, and the universe will contract upon itself. Although the universe is made up of stars, galaxies, and planets, it also is made up of matter that is not visible. This matter is known as being dark matter. Dark matter is going to be any planets, black holes, or brown dwarfs, which are star-like objects, that lack enough mass to begin the fusion process and emit light. Scientists do know that this type of matter does exist because of the way that other light from other sources seems to bend around objects. And this is known as gravitational lensing. So what you may see is from that light source, there's a bend of the light from its source to the observer. And so what you'll see is that gravitational lensing, and thus suggesting that there's some dark matter that is causing that light to occur.